Okay, hi everyone, welcome to this live stream here. Today I'm going to be doing a challenge lab from Boson NetSim. Now covers three topics. Okay, so this will cover HSRP. It will cover OSPF, and it's also going to cover static routing as well, static and default routes. So we've got a lot to get through here. So yeah, let's get straight into this video. Okay, it should be a good video, a good lesson, I think, for us to discuss all these topics now, and look at how we can configure. And so in this lab, we're going to configure iOS routing features on a network with multiple VLANs. Now, you will explore a previously configured implementation of Hot Standby Router Protocol (HSRP). You will also configure default routes where appropriate. Finally, you will configure single area OSPF to route packets between IPv4 networks. Now, ideally, you should complete this lab once only after you complete all the labs that cover this material. Now, so the topology we've got router 1, you can see here, router 3 serial link there, router 2 connected on the left hand side. Then you can see router 2 is connected to a layer 3 switch. Router 3 is also connected to a layer 3 switch. It looks like we've got an ether channel here, and then we've got then we've got these access level switches here. AS access switch 1, access switch 2, that's distribution switch 1, distribution switch 2, router 3 connected to router 1. So the first question, HSRP is a FHRP, first hop redundancy protocol. Yeah, it's a Cisco proprietary that is used to ensure devices on a local network always have a default gateway to which they can forward packets. If one gateway in the HSRP configuration goes down, another takes over for it. In the task, you will explore an existing HSRP configuration to verify that HSRP is functioning correctly and to determine which devices are active routers. Right, so allow the network to converge then from PC1, trace the path to PC4. Okay, so what we're doing, we're going to explore an existing configuration of HSRP to verify that HSRP is functioning correctly and to determine which devices are active routers. Now, let's ping from PC1 to PC4 192.168.200.6. So we've got PC1. I'm going to ping 192.168.100.6. 200.6. Sorry, my apologies. 200.6. So we're pinging that device from we actually trace routing to that device. Sorry, trace. We do trace RT. Sorry, my command line's a bit slow. Here we go. Trace. Okay, so we do 192.168.100.2, 192.168.200.6. So there's an intermediary device there that's we're passing through from PC1 or PC4, so we can trace the path back to PC1. So just confirm the IP address of PC1. It's 192.168.100.5. Ping 192.168.100.5. So again, replies now. Just let's do a trace route. Sorry, just trace RT. 200.1, 100.5. Okay, so it's taken a different route than PC1 was to PC4. So we can see 100.2 and 200.6 on PC1. Yeah. So based on that port, you can determine that the trace route packet from PC1 is forwarded to DSW's distribution switch 2's VLAN 100 interface. Okay, so PC1 did a trace route to PC4, passes through that distribution switch 2. Yeah, forwarded to that distribution 2's VLAN 100 interface 100.2. Next, the packet is forwarded from distribution switch 2 to PC4. PC1 resides on VLAN 100, PC4 resides on VLAN 200. Because PC1 is capable of communicating with PC4 even though they reside on separate VLANs, you can summarize that distribution is routing traffic between VLANs, although PC1 is configured with the default gateway 192.168.100.15. You can see we've got an Ether channel here, so it looks like we don't have to leave the entire network because we've got we can just go through the distribution switches now. Alright, so you can surmise that distribution switch 2 is route traffic between VLANs, although PC1 is configured with the default gateway 192.168.100.15. This IP address does not appear in the trace route output, okay, because it looks like we're just going through those through the distribution switches. Okay, it looks like we're just going through the distribution switch to get to our destination. If we did the trace route backwards. Now you can determine that the trace route packet from PC4 is first forwarded to VLAN distribution 1's VLAN 200 interface. Okay, it's nicely been the IP address has been configured as 200.1, indicating the VLAN. So we can see 200.1. We can see VLAN 100 and VLAN 200. Here 200.1 is VLAN 200s on connected to VLAN 200 on distribution switch 1. Now, okay, so based on that port, you can determine that the trace route packet for PC4 is first forwarded to distribution switches 1's VLAN 200 interface because PC4 resides on VLAN 200. Next, the packet is forwarded to PC1. This indicates that distribution switch 1 is also capable of routing packets between VLANs. PC4 is configured as default gateway 192.168.200.15. Okay, PC4 is configured with the default gateway of 192.168.200.15. Yeah, which it's going to be distribution 2. 200.15 is connected to HSRP group 2. Okay, so issue the commands to display information about HSRP configurations on each layer 3 switch. So to review the HSRP configuration, we can do which command would we use to view HSRP configuration details for HSRP? I'm just double checking myself. HSRP information. Just quickly checking my book. So if we do show standby is a good command, sorry, and that will show you information about if preemption is enabled or not, about the active router, the standby router. You can see the priority. You can see several details here. Yeah. So if we do, I'm just checking this official cert guide as well. When it comes to first hop redundancy protocol, hot standby route protocol. Now, just on the topic of FHRP, I'm going to put in the description, I'm going to make a short video about this as well. There's virtual MAC addresses that we should know. Alright, so you got quadruple.0c9f.fxxx, right? So that is the virtual MAC address of HSRP version 2. Quadruple 0.5e00.01xx is for VRRP version 3. And you've got 0007.b40x.xxrr is for GLBP. And this is one of the key topics for the CCNA when it comes to HSRP. So it's important to know about that. But yeah, if we do show standby, it should show us the information that we need to know. Okay, I'm going to move quickly through this because actually configuration is not mentioned. When it comes to HSRP, first top redundancy protocols, generally, what the CCNA asks in 3.5, section 3.5, is describe the purposes, functions, and concepts of first top redundancy protocol. So it's not actually mentioned about configuration, but it was part of this lab. That's why I'm doing it, and I think it does help learn more as well when you know how to configure something as well. But if you do show standby, that should show us the information we need to know. So for DSW1 and DSW2, I'm going to try and move through this quickly, and I'm going to try and get this lab done in the next half an hour. So if we do enable show standby, we can see here information now. You can see virtual IP address, the virtual MAC address. So that's the default for version 1. So again, I was saying that that when it comes to HSRP, learning how to configure does help, I think, for long-term memory. So that's the virtual MAC address for this. Okay, so we can see 0000 dot 0c07.b.ac64 is there. Yeah, so for HSRP, no, let's not get confused. For HSRP version 1, you got HSRP version 1 and version 2. Version 1, version 2, you've got different MAC addresses. So this is version 1's MAC address, default 0000.0c07.acxx. Yeah. So if I'll put this in the description of our. I will put this in the description, by the way, as well, of the lab. But that's something important to know about, is that a virtual MAC address that's the default for version 1. Sorry, just taking the screenshot there of that. That's something very important to know about now. Let's get moving on to the next thing. So I will make a short video about those MAC addresses, because yeah, important to put on your flashcards. Know those MAC addresses, virtual MAC addresses. Know the multicast addresses that HSRP uses in version 1, version 2, and then VRRP and GLBP as well. Something important to know about for the exam. Show standby. Show standby on here. We can see for VLAN 100 and 200, we see separate virtual MAC addresses. Preemption is enabled. Let's now go into distribution switch 2. Run enable conf. Don't need to run conf t now. Show standby. Let's also see here the you see version 1 default being used there. Another version 1 default there for actual virtual MAC address. Go back to the document. Let's have a look. Based on output, you can determine that HSRP group 100 is configured on the VLAN 100, but interfaces of both DSW1 and DSW2. HSRP group 100 shares a virtual IP of 192.168.100.15, which is the default gateway address that is configured on PC1 and PC2. HSRP group 100, HSRP group 100. You can see HSRP group 100, group 200. Yeah, so you can see that shares a virtual IP address 192.168.100.15. Yeah, virtual IP there, 100.15. It's the default gateway address that is configured on PC1 and PC2. So we run show standby on DSW2. We can see that virtual IP is the one that PC1 and PC2 are pointing to. Okay, that virtual IP address 100.15, and on 215 is the similar thing that, that for example, PC4, 200.15 is his virtual IP address. So it's his default gateway, which is the virtual IP address, the virtual IP that this uses, okay? Because in HSRP we have virtual IPs, right? We've got multiple routers, which are actually in the topology. So yeah, so that is the virtual IP, okay? So it has virtual IP, yeah, which is also the default gateway PC1, PC2. Similar thing going on here. We've got a virtual IP address, yeah, for DSW2, which is 100.15. Sorry, if on VLAN 200 is got 200.15, which is what the default gateway of PC4 is, 200.15. Right, so we've got two VLANs there. Two VLANs, yeah, 100.15, 200.15. So based on that port, you can determine that HSRP group 100 is configured on the VLAN 100 interfaces of both DSW1 and DSW2. HSRP group shares 100 shares a virtual IP address of 192.168.100.15 with the default gateway address that's configured on PC1, PC2. DSW1 is the active router for HSRP group 100. DSW1 is the standby router for HSRP group 100. This is because DSW2 is configured with the HSRP priority higher, right? So it's the standby router for HSRP group 100. That's because DSW2 is configured with the highest HSRP priority than DSW1 for HSRP group 100. So I'm going to repeat that again. DSW2 is the active router for HSRP group 100. DSW1 is the standby is the standby router for that HSRP group 100. So DSW is the active. DSW1 is the standby because DSW has a group configured with a higher HSRP priority than DSW1 for HSRP group 100. Therefore, it's the king. Yeah. By default, HSRP uses a priority value of 100. Now, if priorities are equal, the router or layer 3 switch with the highest IP address becomes the active router. Okay, if the priorities are equal. All right. Now, in here we can see the priority for yeah, you can see DSW1. You can see a priority there for 99. It's configured as 99. Yeah. And for DSW2, priority is 101. It's higher. It becomes takes a priority. Failing that, you would look at the, and this is something also important to remember, the highest IP address. Yeah, highest IP, virtual IP there, virtual IP there, 115, 100.15. Yeah, virtual IP address there. Yeah, standby router is 100.1, priority 99. Active router is local. Active router is 100.2. So 100.2, 100.1. So this is something really important to note down, and I will put this in the description as well, but I would like you to note it down as well. Is when it comes to HSRP priority values. Now, furthermore, DSW1 will, so yeah, we've got HSRP use a priority value of 100. Priorities are equal. The router or layer 3 switch with the highest IP address becomes the active router. Now, this scenario, DSW1 is configured with a priority value of 99 for HSRP group 100. Therefore, DSW1 will never become the active router because unless the HSRP group 100 configuration on DSW2 goes down. Furthermore, DSW2 will not remain the active router if the DSW2's HSRP group DSW2's HSRP group 100 configuration goes down and then is restored. Okay, because DSW2 Okay, it will not remain the active router if apologies. So DSW2 is the active router for group 100. DSW1 will not remain the active router if DSW2's HSRP group 100 configuration goes down and then is restored because DSW2 is configured with HSRP preemption. HSRP on DSW2 will force route election, and when it comes up again, while with the existing priority configuration, DSW2 will always win the active router role for HSRP group 100. Okay. So there's preemption. So this means that packets destined for remote networks that are sent to VLAN 100, which contain the subnet on which the VLAN 100 interface is configured, will always be forwarded to DSW2. Packets destined for remote networks that are sent from VLAN 100, which contain the subnet on which the VLAN 100 interface is configured, which contains the subnet on which the VLAN 100 interface is configured, will always be forwarded to DSW2. First, these packets will only be forwarded to DSW1 if DSW2's HSRP configuration goes down. So I think this what it's meant to say was that DSW1 will not remain the standby router if DSW2's HSRP group 100 configuration goes down, then is restored. Oh, sorry. No. Yeah, it was just the way it was worded. Yeah, DSW1 it would become the active, but if it was restored, if DSW2 came back up, you got DSW2 right now is the king. If that went down, DSW1 would become the king, the active router. If that went, but if DSW2 was to come back online, it would kick off DSW1 because of preemption. Now this means that packets destined. So yeah, we talked about packets being destined for remote networks for sent from VLAN 1 to which contains subnet on which the VLAN 100 interface is configured. It's always going to be forwarded to DSW2 first. These packets will only be forwarded to DSW1 if the DSW2's HSRP configuration goes down. Now, by contrast, DSW2 is the standby router for group 200 because DSW1 for HSRP group 200 is a priority of 99. You can see that 99 for 200. Yeah, it's DSW2. You can see priority 99 there. Here, you can see VLAN 200, to state changes, 200.15, virtual MAC. To run show standby again and show more information. You couldn't see everything there, but you can see now priority is greater. So while so for this kingdom, VLAN 200, DSW1 is the active route, is the king, so to speak. So right. So yeah. By contrast, DSW2 is the standby router for HSRP group 200 because DSW1 for DSW2 is the standby router for HSRP group 200 because DSW1 for HSRP group 200 has a priority value of 99, while HSRP group 200 for DSW2 has a priority value of 101. Therefore, DSW will always win the active router role for HSRP group 100. This means that packets sent destined from remote networks that are sent from VLAN 200, which contains subnet on which the VLAN 200 interface is configured, will always be forwarded to DSW1 first. These packets will only forward to DSW2 if DSW1's configuration goes down. Okay, so they'll be sent from VLAN 200. They're gonna go. Okay, they're gonna go to DSW1 first. Now, the question number 4 on DSW1: issue the command to display the routing table. Note the gateway of last resort configuration. So let's run on DSW1. Let's do show IP route. We can see various routes here. So if you want to see the gateway of last resort, well, apparently it's not set. So saying there's no gateway of last resort set. I can't see any 0000 configuration. You can see routes to 51.100, 68.100, 68.200. So let's have a look what it's talking about here. So it's not set. Okay, the question is slightly misleading. You can determine that only local and connected paths exist in the routing, and there's no static routes, no default routes, no routing protocols configured on DSW1. Therefore, DSW1 is performing inter-VLAN routing because the device itself has IP routing enabled and is configured with interfaces that reside on both VLANs. So it's performing inter-VLAN routing because the device itself has IP routing enabled and is configured with interfaces. It's performing inter-VLAN routing because the device itself has IP routing enabled and is configured with interfaces that reside on both VLANs. Yeah, we've got interfaces. Yeah, IP routing enabled, configured with interfaces that are on both VLANs. So DSW1 is doing some inter-VLAN routing itself here. There's no default route. Okay, and let's also have a look at DSW2. Yeah, so just to do show VLAN, I just was interested in seeing this. VLAN 1 to 100, 200, see it's counting sales. So yeah, there is no gateway of last resort. So configured here. Let's issue the commands to disable HSRP group 200 now, 100, sorry. Okay, we need to disable the group. How would we do that? How would one disable the HSRP group? Sorry, I'm just checking my book, but we want to disable the HSRP group for 200. Let's have a look at what the document says. So we need to issue the commands to disable group 100. So what we do is interface VLAN 100. We just shut down that that VLAN there. That will change the state to administratively down. So based on the output, you can determine that VLAN 100 interface on DSW has been disabled. In addition, HSRP group 100 has transitioned to the init state. Okay, so initialization state, you should see the following message on your console after you disable 100, that VLAN 100. So this the output voucher indicates that DSW1 has transitioned from the standby mode into the active HSRP role for HSRP group 100. Okay, so let's because yeah, if we DSW1 was configured with the high priority for group 200, so it was active it was the for standby for VLAN 100 for group 100. It was the DSW2 was the active for group 200. VLAN 1 was the active, but if you disable HSRP group 100, if you shut down that on DSW2, that will make DSW1 king for both groups. Will make it the active route for both groups. So if we do, if we go into the conft, we do interface VLAN 200, and we shut down that on here. Sorry, 100. We come out that interface VLAN 100. Shut that down. There we go. So interface VLAN 100 change state to administrative down. VLAN 100 stay active. Changed in it. Now, if we are to keep reading here, apologies, my eyes straining a bit. So the above output show indicates that DSW1 is transitioned from standby role into the active HSRP router role for group 100. So yeah, if you go to DSW1 now, you can see VLAN 100. We can see it's changed from standby to active. Yeah, so it's now the active for both. If you were just to do show standby, we can now see, okay, we can see that it's active for both now. Yeah, active on group 200, active on group 100. Brilliant, 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 brilliant. So HSRP routers transition through several states when they are first configured, and when a router election occurs, a router enters the init state after it experiences a configuration change or when an interface becomes available. From the init state, the router progresses to learn state, where it determines the virtual IP address of the gateway and waits for hello packets from the active router. Once the router has learned the virtual IP address, the router progresses to listen state. From the listen state, the router enters the speak state and actively participates in the HSRP election process. A router that is not elected or as the active standby router will remain in the listen state. It's going to remain in the listen state. In the listen state, the router will listen for hello packets from the active and standby routers. Typically, there's only one router in the standby state and one router in the active state. So I'm going to repeat that again. HSRP routers transition through several states. The transition through several states. Okay, they transition through this. We're talking specifically about HSRP. So a router enters the init state after it experiences a configuration change or when an interface becomes available. Okay, an init state. Configuration change when interface becomes available. So we saw here init state. DSW2 went into init state. Yeah, from active. Yeah, so it fell from grace, went into init state. From init state, the router progressed to the learn state, where it determines the virtual IP address of the gateway. The virtual IP address, the gateway. It will learn the virtual IP address of the gateway in the learn state. Waits for hello packets from the active router. Okay, so once the router has learned the virtual IP address, and the rest, okay, so it's learned the virtual IP address. It will, first it determined, waited for the gateway. So it determined the virtual IP, address of the gateway, waited for the hello packets from the active router. Okay, so it's like it's getting ready to waiting for the active router. It's like kind of you're waiting in line, to be to meet someone special. It's kind of like that. Once the router has learned the virtual IP address, the router progresses to the listen state. Learns the virtual IP address, goes to the listen state. From the listen state, the router enters the speak state. The speak state actually participates in the election process. A router is not elected, as the active or standby router will remain in the listen state. In the listen state, the router will, so if it's not been elected, not got one of the two big jobs, in the listen state, the router will listen for hello packets from the active and standby routers. Okay, typically there's only one router in standby state and one router in the active state. Okay, a standby router will assume the active state if it does not receive any hello packets. All right, it will assume the active state if it does not receive any hello packets from the active router for the duration of the hold time, which is hold down time, which is by default 10 seconds or 3 times the hello timer. Yeah, either one of the two. After the active standby router assumes the active state, the router with the next highest priority in the listen state assumes the role of the standby router. A router will only enter the speak state if a router with a high priority becomes the active router. Once the emptied router determines standing in the router group, it will transition to the listen or the standby state. So if you've got a notepad pen with you, if you're on your computer, I would like you to please note down some key things before we move on, because we've read some very important information. So I would like everyone to watch in. If you guys, if you're able to, please let's write down some key details. One is the default this default time. Okay, so standby router will assume the active state if it's not received any hello packets from the active router for the duration of hold on time, which is by default 10 seconds or 3 times the hello timer. Okay, so after the standby router assumes the active state, the router with the next highest priority in the listen state assumes the role of the standby router. I'd like you to think about the states that we've been talking about. Okay, so I'm just taking a note myself as well. And it's also important to note that for first hop redundancy protocols, your preemption is disabled by default. Okay, Yeah, it's not enabled by default. So hope everyone's had an opportunity to do this, to quickly note down those default timers, yeah, for the default hold on time. Now, another important thing I think is important to know about is these states. So just knowing these different states, okay. So which states does HSRP transition through? Okay, we spoke about init. You've got the init state. You've got the learn state. Yeah, and then we had the listen state. We had the standby and active. Okay, only one active, and typically you only have one route in standby. So that is what I just wanted you guys to note down. Don't think there was anything else in particular. So let's move on. Let's trace the path now to from PC1. Trace the path to PC4. Let's trace the path to PC4. PC1 to PC4. So let's run that again. The command we ran earlier. Sorry, this has run over time, so I do apologize about that. I'm gonna try and I've got still a bit to get through, quite a bit. Task 2 and task 3. So I'm gonna try and query things along and get this done within the next half an hour. We've already got 36 minutes, almost 37 minutes through. So what we need to do next is let's run that trace route again on PC1 to 200.6. It's gone through it's gone through 100.1 this time, and then to 200.6. So it's taken a different route. Remember that what did we do? We've made DSW1 is no longer the active now for group 100. Okay, and so that the IP address that we see here, 101 now rather than 102, that's the IP address for DSW1. Yeah, 100.1 is VLAN 100, the one that's connected to VLAN 100. Yeah, because it's taken that route now. It's going from there to there to there to there, not there to there to there to there. It's going from there. All right, it's going from there to there to there. Yeah, there. Okay, we don't see that in the table, but we don't see that in the trace, but it's going to there. Default gateway goes to PC4 because originally it would have gone via that, but it doesn't do that anymore. So let's get back down. What are we doing now? Okay, we do the same trace route here. So we go to 100.5 now, and it's gone through 200.1, which is fine. You can see so. All right, so for that first command we did PC1 now force packs first to DSW1 instead of DSW2, because DSW1 is the active route to 400 group 100 now, and this path has not been altered by disabling VLAN 100 interface, because PC4 resides on VLAN 200. It's sub group 200, which is configured on DSW1's and DSW2's 200 interfaces, remains active. Okay, so it was taken that route originally because that was the active route for its group. So I think nothing really changed for PC4 now. On DSW1 issue the commands to disable the VLAN 200 interface. Let's go here. Let's now disable conft interface VLAN 200. Let's disable that by doing a shutdown. Sorry. So VLAN 200 is being disabled. Yeah, because remember VLAN DSW1 was the original king for that, the original, I say king, active router for that group. So now we're kicking DSW1 off. Yeah, we are now taking, yeah, we are taking that job away from it now by disabling that VLAN 200 interface. We disable it. All right, so what happens? VLAN 200 is disabled on there. And what happens? We can see preemptions happened. DSW2 is now taken over. Right, so DSW1's kicked out of that role, and DSW2 has taken over. So we can see what's happened here. So we can see it's transition to the interstate. This means DSW2 is now the active router. So DSW2 is now active for VLAN 200. Now on DSW1, issue the command to enable the VLAN 200 interface. So if we now, sorry, if we go here, yeah, we re-enable that interface, what's going to happen? So let's have a look. End conft interface VLAN 200 no shot. So that's changed. So VLAN 200, it's now, what's going to happen? What would happen? What do you think? Well, it's configured the priority 101 for VLAN 200. And if you were to do show standby here, sorry, do show standby, you can see that for VLAN 200, it had the lower priority. So it's lost his, basically, it's going to lose his job again. Okay, so VLAN DSW1 should be restored now. It should have his job back as the active. Yeah. So it's got its job back, yeah? So yay for DSW1, it's got its job back. It's the active router again. On DSW2, we're going to enable the VLAN 100 interface. So hopefully, we're going to, if we do interface VLAN 200, we no shut that now. We no shut, sorry, not shut. We're not shutting down VLAN 200, so we're doing no shut for 100 because that's the one we disabled. We shut down VLAN 100. We do no shut now. Let's change the status. Now that should now become the active again because he had the high priority. Preemption works. It gets its job back. So now we can see that's got its job back. And now let's trace the paths again. Hopefully this should be, we should see that they take the original paths again. So we do trace route to there. We can see it takes the original path again. It goes through DSW2 and then do DSW6. And for here, if we do the trace route again, we'll see, oh sorry, trace RT. So we do another trace route from, sorry, I'm doing it from the wrong place. Let's do another trace route to 100.5. So one PC4 wants to talk to PC1. Should take back, it should, you can see it's still using the same route. It's not really, nothing really changed because it was, remember, it's for that PC1 is in VLAN 100, which it was connected, and for, sorry, PC, it's not going to change the route for that, okay? You can see that DSW1 routes package for HSRP group 200, okay? So if we go back there, 100.2, yeah, see 100.2 from PC1, you see 200.1. Okay, so 100.2 was, if you look at 100.2, you see 100.1, 200.1, 100.2, 200.2. PC1 is taking the route, is going to via DSW2. It's going via DSW2 again, yeah, which how it was doing right back at the start. It was doing that. It was using that route, okay, because it's got its job back now. It's the active router, okay. it uses that route, all right, like it was at the start, 100.206, yeah. PC1 forwarded to DSW2's VLAN 100 interface. The packets forwarded from DSW2 to PC4. PC1 resides on VLAN 100. PC4 resides on VLAN 200. Because PC1 is capable of communicating with PC4, even though they reside on separate VLANs, you can surmise that DSW2 was routing traffic between VLANs. Okay, although it's configured with the default gate 100.15, it was using that. Right now, it was 100.15. So yeah, it's got a different default gate. The default gate was 100.15, yeah, which is the router, but yeah, 100.15 was something. Yeah. Okay, so 100.15. Looking at 100.15, I can't see that in this table. There it is. 1 and 268. So it's not the router, sorry. It's configured with default gate 100.15, yeah, which is our group 100's IP address. This IP address does not show in the traceroute output, right? It was going through 100.2. It's now going through 100.2 again. So that is everything there for and yeah, for PC4 perspective it's the same. It goes through 200.1. It goes through it goes through 200.1, yeah, which is which is DSW1. It was going through there anyway. It carries on going through there. So PC4, nothing's changed the whole time. Now, let's move on to configuring default routes and static routes. So in this task, you will configure default and static routes on several devices in the topology. Default routes for traffic to unknown destinations to a router. Sorry, they forward traffic to unknown destinations to a router. Now, static routes for traffic for specific networks to a specific next hop or interface. Sorry, just a second. So, in task, we will configure default routes and static routes on several devices in the topology. Default routes forward traffic to unknown destinations to a router. Static routes forward traffic for specific networks to specific next hop or interface. This is very important. Default routes forward traffic to unknown destinations. Forward traffic to unknown destinations. Yeah, the forward traffic to unknown destinations to a router. Static routes forward traffic for specific networks. Okay. Yeah. So I think default routes for traffic to unknown destinations for a router would probably be a bit better, would make more sense there for a router. Yeah, unknown destinations. Yeah, 0.0.0.0. Yeah, you must have probably seen that IP address. Yeah, static routes online for traffic for specific networks to a specific next hop or interface. Yes, it's manually configured. Yeah, so don't get confused by these definitions. Default route 0.0.0.0. Yeah, is for uses that address when there's no. Well, we can't find a match, we just send it through the default route. Yeah, static route is manually configured. You have specific hop networks to a specific next hop or interface. So from ASW1, what we're going to do is ping DSW1's VLAN 100 interface and DSW2's VLAN 100 interface. The pings should fail. Okay, so ASW1, let's go to ASW1, access switch 1, and we've got access switch 2. So what we're going to do is ping DSW1's VLAN 100 interface. So 192.168.100.1. So from ASW1, enable conft ping 192.168.100.1. Let me enter do there. That fails. And then from here, we're going to do 100.2 from DSW2. We'll ping 100.2. So DSW2 192.168.100.2 from ASW1. Sorry, I think I pinged from the wrong device. From ASW1, we're pinging we're pinging DSW1's VLAN interface. ASW1 from ASW. Sorry, there's so many devices. I was getting confused. ASW1, we're pinging DSW1's VLAN 100 interface, and from ASW1 also pinging DSW2's VLAN 100 interface, which is 100.2. So does that work? ASW1 ping DSW1's VLAN 100 interface 192.168.100.1. That didn't work. That didn't work either. 0%. Sorry. Yeah. So. Yeah, success rate is 0%. I saw success first and I was thinking, that work. No, success rate is 0%. So both of those failed, like they should have. So ASW1 can't ping DSW1's 100 interface or DSW2's VLAN 100 interface. Yeah, the pings fail even though ASW1 is configured with an interface that resides on the same VLAN as the VLAN 100 interfaces of DSW1 and DSW2. Yeah, so they fail even though ASW1 is configured with an interface that resides on the same VLAN as the VLAN 100 interface on DSW1 and DSW2. This is because layer 2 switches must be configured with the default gateway in order to correctly send and receive a reply to ICMP packets. Okay, they need a default gateway. So they're configured with an interface that resides on the same VLAN as the VLAN 100 interfaces on DSW1 and DSW2, but the pings still fail because they need a default gateway configuration. Now, on ASW1 and ASW2, issue the commands to configure each switch to the default gateway. Yeah, so we need to configure default gateway for both of them on both switches, on both access switches. So how are we going to do that? IP default gateway. Yeah, in global configuration mode, yeah, we configure the default gateway. Yeah, and a default gateway is also known as default route or gateway of last resort. Typically, these default routes are statically configured to which packets destined for unknown networks are forwarded. When a host networking device sends a packet that's destined for an unknown network, the packet is forwarded to the default gateway for further routing. The default gateway might already have a path to the destination. If not, the default gateway might forward the packet to its own gateway for last resort for the routing. So let's go enable and let's go IP default gateway 100.15. Yeah, 100.15 there, and then 200.15 after. So 192.68.100.15. And let's also configure so on that's ASW1. ASW2 we need to configure 200.15 as the default gateway, right? So because if I were just to do show IP interface brief here, this is DSW1. That's DSW1. Show IP interface brief. That's not showing what I wanted to show. 100.15 and 215. I wanted to show 100.15, 200.15. Those are okay. We've got different HSRP groups. 100.15, 200.15, 100.15, 200.15 for these different HSRP groups. We are trying to configure 100.15 for HW1. Yeah, and 200.15 for HW2. So IP default, conft IP default gateway enable conft IP default gateway 192.168.200.15. 200.15 there. Yeah. Sorry, I was just typing a note. So from HW1, ping DSW1's interface 100.1 and DSW and VLAN and DSW2's VLAN 100 interface. Okay. So DSW1's 100 interface and DSW2's VLAN 100 interface. Yeah, so we got. So DSW1 uses 100.1 for VLAN 100. DSW2 uses 100.2 for VLAN 100. DSW1 uses 200.1 for VLAN 200 and then 200.2 for DSW2 uses 200.2 for VLAN 200. So the clue is in the third octet, yeah, that indicates the VLAN that's connected to. So what we're trying to do now is let's go into so we from HW1 we're going to ping DSW1's VLAN 100 interface and DSW2's VLAN 100 interface from HW1. Yeah, so yeah, we configured for the gateways. We configured something different. We configured these HSRP group, the HSRP group for HW1. We configured 100.15 for HW1, and for the group VLAN group HSRP group 200 we configured 200.15 on HW2. But now let's from ASW1 let's ping 100.1 and let's ping 100. Was it 100.1 and 100.2? That worked. That also worked. So that's great, right? So these pings have succeeded. Yeah. So we can issue pings now to DSW1's 100 VLAN 100 interface and DSW2's VLAN 100 interface. We can ping both of their from DSW1 we can ping HSRP groups VLAN 100 interface and DSW2's VLAN 100 interface. Right, so from DSW1 and DSW2, ping router 2's fast Ethernet 2.0 interface. From DSW1 and DSW2, ping router 2's fast Ethernet 2.0 interface. From DSW1 and DSW2, we need to ping router 2's fast Ethernet 2/0 interface, router 3's fast Ethernet 1.0 interface, and router 1's 0.0 interface. We need to pay attention to which ones succeed and which ones don't succeed. DSW1, let's ping fast Ethernet 2/0 interface, and then the 3/0. So then the router 3's fast Ethernet 1.0 interface, and then router 1's 0 interface. So we can see all the interfaces here for DSW1. So we're looking at we're trying to ping router 2's fast Ethernet 2/0 interface first. So ping, copy that address 108.51.100.1 router 2. Sorry, from DSW1. So let's ping it. Let's just do 5 pings. So I wasn't supposed to do that. I was just trying to do it. Just wanted to do that. So that's worked. Let's try from DSW2. Ping distribution switch 2 and distribution switch 1 can both ping router 2's fast Ethernet 2/0 interface. Sorry, they can both ping the 2/0 interface. Yeah. So the 2/0 interface yeah, 198.51.100.1, they both can ping that interface. So those are the interfaces that it has. They're both capable of pinging that 2.1 interface on, yeah, DSW1 is. DSW2 can also ping that. Now let's ping route 3's fast Ethernet 01 interface. Sorry, 1/0 interface. Router 3, by the way, I just want to see I just want to run SHARP interface brief just so I can see all of its interfaces. Router 3. We are pinging that guy here. So if I were to go to here, ping, that worked. Now, will this work? Will this not? Well, at the moment, can't think of a reason why it wouldn't. It does work. Now let's ping router 1000 interface. Right. Router 1 has a 00 interface. Yeah, the 00 interface 203.0.113.3. DSW1. Can it ping that guy? DSW2, can it ping that guy? Right, so DSW1 couldn't ping it. And I don't think DSW2 is because of those dots that are appearing. So I think we've got a problem there. Everything else seemed to have worked. So no, that's not worked. Let's have a look quickly at what's happened. Why has that not worked? Sorry, this lab is really overrunning us again as well. So I know it's going to be a very long video. We've already gone over an hour, exceeded an hour. So I'm going to try and speed things along because I don't want this to go over 2 hours. Definitely not. So on route 1, so we can see here the pings to route 2 and route 3 succeed because the routers have passed back to DSW1, DSW2. Route 2 and route 3 reside on the same 198.51.100.0/28 network as the VLAN interfaces that are configured on as the VLAN 1 interfaces that are connected on DSW1 and WS2. Okay, so we need to think about this. DSW1, DSW2. If you just do show IP interface brief, they've got VLAN 1 interface 198.51.100.3. Yeah. So, if I were to just, by the way, just do show IP interface brief here. So, we can see VLAN 1, 5100.4, 100.3. We were pinging IP addresses that were in the same VLAN there. This is something completely different. It doesn't have 203.0.100.13. Doesn't know how to get there. So yeah, this is right on the same network as the VLAN interfaces that are connected on DS.1, DS2. Yeah, this they have no path to. So no path. Yeah, route 1 has no path to the 192.168.100.0.28 network or the 200.0.28 network. If you were to look in, they've got no. So we tried pinging route 2 and route 3 on fast Ethernet 00 interface. Fast Ethernet interfaces. But route 1 serial interface. If you were to look at his routing table, I can't see 192.168.100.1 to whatever they're not there. So the distribution switches on interfaces, 51.100.3 and 198, sorry, 198.51.100.3, not 192.168, 198.51.100.3. Is there a route there for that? 198, there's nothing there. We've got connecting local routes, but we've got nothing for 198.51. So they've got no path, yeah, no path to that 200. So yeah, DSW1, DSW2, they don't have a path. Router 1 does not have a path to those networks that this exists on. 192.168 or 198.51. It doesn't have a path to even these 192.168 addresses. So the server race to ensure that DSW1 and DSW2 can ping router 1's network in this scenario. First, you could configure static route to each network on the appropriate devices. For example, we could do this: IP route 192.168.100.0, 255.255.240, 203.0.113.6. Okay. On router 1, we can configure that. Yeah. So to get to this network, this subnet mask, that's the next hop, 203.0.113.6. If you look in our information that we're going 203.0.113.6, that's .5 there. That's router 2, 203.0.113.6. So router 1 could go via router 2 to DSW1 because that's the intermediary device there. So it needs to go through there. So that's what could happen. That's what we could do. Yeah, to ensure that any package destined for the 192.168.100.0/20 network are forwarded to router 1's next hop interface of on router 2. Yeah, which is that 203.0.113.6. So however, this command only passes traffic that is destined to the 192.168.100.0/20 network from router 1. It will not apply to traffic sent to router 1. To router 1 from DSW1 or 2. Okay, so this is one way. This is just going from router 1 to DSW1, DSW2. Adding a default route to router 1 that forces traffic to unknown destinations to the next hop interface on router 2. So adding a default route to router 2 that forces traffic to unknown destinations to the next hop on router 2 will ensure that any packets router 1 forward to unknown networks are sent first to router 2. And third option is to configure routing protocol dynamically and pass to networks that reside on other routers. Alright, to configure something like OSPF. Yeah, that we can dynamically on routes. This is statically, this is manually doing it. Whereas OSPF is something which is or HSRP. These are routing protocols which can learn routes themselves. Okay, so on route 1, issue the commands to configure last gateway last resort with the next hop address of 123.0.113.6. We need to issue a command to configure gateway of last resort with that next hop. Right, so 203.0.113.6. So what we could do, which is basically saying you don't have a route to this network, use this next hop address. So if I remember correctly, the way to do it is conft IP route 0.0.0.0. We do 0.0.0.0 again, and then we paste that address. Right, it's not like that. Why not? Oh, sorry, I've got a dot at the end. That's worked there. So hopefully, that's the way we do it. Yes. So unlike a normal static route, default route replies on the network address of 0.0.0.0, wildcard mask of 0.0.0.0 to represent all remote networks. The final IP address in the command in the next hop route or 203.0.113.6 instead. Sorry, I'm speaking so fast. The final IP address in the command is the next hop IP address of 203.0.113.6. Now, instead of supplying a next hop address, you could use the outbound interface name, time, and slot number. For example, you could do that as well. Yeah, you could do that as well, because you got FastEthNet. Sorry, you could do FastEthNet 1.0. you could do that as well. Yeah. The outbound interface name. Now that interface, by the way, is going to be the interface, outbound interface on the device. We're not talking about router 2's interface. We're talking about the interface that's facing router 2's interface on router 1. That's what you could specify, or you specify the next hop address of that neighboring device. In this case, is router 2. Okay, so the outbound interface version of the command requires extra overhead from the router when forwarding packets. Now, on DSW1, let's issue the commands to ping router 1's that serial 00 interface again. Okay, to ping the router 1's serial 00 interface. Yeah, so let's go here. I don't know why they tell you the outcome before you've done it. It would make more sense. But here we go. Still can't ping. Now, that's I was just saying, I think it would have been probably beneficial if we didn't have the outcome revealed there, but yeah, the ping has failed, and because there's no route at the moment. DSW1 has no path to that network. Okay, we've configured something on router 1 telling it about how to get to DSW1, but we've not configured something the other way. If we were to ping, by the way, I want to try a ping test, even though it's not asked us to do it, but let's do a ping test. So if we were to do that ping from here, to ping that 192.168.100.1, that still doesn't work. Still doesn't work. That doesn't work. You'll probably be able to ping. We should be able to ping. Let's try the VLAN 1 interface. I'm just interested what's going to happen to ping DSW1's. If I try and ping that, will that work? Again, do ping. Yeah, that doesn't work either. But let's do... No, that's not working. But anyway, we've not been asked to do that. What we've been asked is ping that 00 interface. We can't ping router 1 00 interface. No path exists. Router 2 lies between DSW1 and DSW2. Router 2 actually doesn't even have a path to that. Router 2 doesn't have a path to 198.51.100.1. Actually, 198.51.100.1/32. So router 2 lies between DSW1 and router 1, sorry, by itself. Router 2 has no path to 203.0.113.0/30 network. Nor does it have directly no path back to the 192.168.100.0/28 network. Therefore, router 2 does not know where to route packets to unknown networks. So what we saw was slash. There's no slash. What we saw was. So one thing at a time. Router 2, there's no path to that 203.0.113.30. 203.0.113 .0/30. 203.0.113.0/30. Okay, that's not an exact match there. That's a /24. Yeah, that's a /24. So it doesn't have. When it comes to, by the way, when it comes to these different routes, if we've got, if it's the exact same path, same prefix, you look at the administrative distance, you look at the administrative distance to determine which route is the best one. If they're all different prefixes, then you normally choose by the prefix that matches. But here, we don't see the same. We don't see a path exactly to that. We don't see 192.168.100.0/28. There's nothing mention of that here. So therefore, router does not know how to route packets to unknown networks. On DSW1, issue the command to configure gateway last resort through router to its next hop IP. So that's the next hop IP of route to 198.51.100.1, 198.51.100.1. So if I just to go back to the here, 198.51.100.1 route to fast ethernet 2/0. Yeah, we need to configure gateway last resort on DSW1. Gateway last resort through to its next hop IP. Configure gateway last resort through to its next hop IP address. So okay, so basically what we're saying is on what we're saying on DSW1 is that what we're saying is if you don't have a route, if you don't know where to send a packet to, please send it out of this interface 4, which is the next hop. Next hop address belongs to route 2. That's what we're doing there. Setting that's the default route there. So we've done that. Yeah. Now from DSW1, ping route 1's 00 interface. Note the type of failure the ping reports. DSW1. We're going to ping route 1's 00 interface from DSW1. Ping. And I do at the start. Failed. Yeah, we can't ping that. Couldn't ping it then. Couldn't ping it then. We can't ping from DSW1. We can't ping route 1 00 interface yet. We can't ping it. We still can't ping. Yeah, success rate 0%. You. Based on this, on the output, you can determine that pings to 203.0.113.1 from DSW1 still fail. However, the pings fail with the destination unreachable error instead of a timeout. That's what it means. You can determine that difference by examining ping result character. That indicates destination unreachable. Just a dot indicates a timeout. Yeah, destination unreachable error typically indicates that DSW1 has passed the network, but the host is down or is not operating on the network. In this case, the path DSW1 has to the network is a gateway of last resort. So it has a path to the network, but the host is down or not operating on the network. Our device lies between route 1 and DSW1. There's no path to the network. Route 2 is capable with neither a default gateway nor static routes. So you can determine that the ping result character, the difference. Sorry, you can this is destination unreachable. That's what it means. So there's a path. DSW1 where we're pinging from has a path to the network, but the host down or is not operating on the network. Yeah. It has a path, but the thing is, that intermediate route 2 does not have a gateway or static routes. So what we need to do on route 1, issue the commands to configure static route to that network that route 1 000 interface belongs to, and static route. So it's like, okay, let's help route DSW1 get there. Yeah, by teaching route 2 how to get there. Okay, the man in the middle, let's teach him how to get there. So that's the static route. Yeah, so we need 2 static routes configured here. One to the 200.3 network. So let's go back to route 2. Let's do IP conf-t. Let's teach this guy how to get there. Okay, so this is your gateway last resort. 00000. Sorry. Sorry, I'm missing a 0 there. Quadruple 0 should be. So it's got a route there. And it needs a static route to 192.168.100.0 as well. Yeah, which I was forgetting back to the DSW1's own VLAN 1 interface. So if I go back, do IP route, in fact, I'll click up arrow. I'll do 192.168. Sorry, 192.168.100.0. Enter. Sorry, not got space. Done. There. Sorry, okay. I've done this wrong, okay. We were supposed to, these are static routes. Sorry, I've done this wrong. We were supposed to get, that I did default route. We're supposed to do static routes. So we'll take those routes out. What we need to do is, it's important to note that configuring a gateway last resort on route points to route 1 would potentially create a routing loop that would cause the device to hang or otherwise not forward packets. Adding static routes to specific networks enables route 2 to forward packets to the correct destinations without creating a loop. Okay, so if that's the problem with what I did. That could create a routing loop. So adding static routes would enable route 2 to forward packets to the correct destination without creating a loop. So what we need to do is take those. We didn't teach it properly. So I'm sorry, I need to go back and take these routes out to the routing table just by doing no at there at the start of that, and also do no there. So what we need to do is, I had a feeling, yeah, this wasn't right what I did. So 203.0.113, let's hide the answer again, /30. So we need to do, if I go back, route 2, IP route, yeah, 255.255.252. What would the next hop be? Next hop is 203.0.113.5. 203.0.113.5 is the next hop. Router 1's fast Ethernet 1.0 interface. Yeah. Which is in fact that was the interface we're trying to reach. So that's the next hop. And then for this one we can do 198.51.100.3, which is VLAN, the VLAN 1 interface. Yeah, public IP address there. So that's how we can do it. So go back to router 2. We need to configure that serial 0 interface 203.0.113.5 as the next hop there. So route 2 as a route to 203.0.113.5. So we configured, the network address, subnet mask, next hop. If we do it now for 192.168.100.0, we'll configure VLAN 1 interface, VLAN 1 interface, that first interface, VLAN 1 interface, native VLAN, as the next hop. And this is /28. Piece 1, DC1, route 2, IP route, there, 255.255.255.2 for /28. It's 240. 198.51.100.1, I think it was. 51.100.3, sorry. .3. Right, great. That's done. Yeah. Let's ping 000 now. It should have everything it needs now to ping that 203.0.113.1. We're trying to ping the serial 00 interface, sorry. Yeah, we're trying to ping the 000 interface. So what we did was 203.0.113.0. Yeah, 255.255.252, 203.0.113.5, which is not the interface sorry we're trying to reach. That wasn't the, oh, I said that wrong. We're not trying to reach that interface. We were trying to reach that one, but this is the next hop. The fast Ethernet 1/0 interface. It doesn't show you which, in packet trace they'll show you like which interface is what, but we're obviously trying to reach the serial interface. But if we do a ping now to that serial interface, it works. Yeah, so brilliant, that works great. Now what we're going to do, let's go back to the document. So we've done that, that's excelente. We've can ping that on route 1, 2 and DSW1, sorry. We need to issue the commands to display the routing tables, and let's see which routes we have now. So if we do end show IP route, you can see, you should be able to see from here a route to that 19. We should see a route. See static route to send to 203.0 or 113.6. Yeah, 213.6, which is route 2's fast Ethernet 01 interface. See that static route which you configured, and we can see let's go see that there. So anything it doesn't know about, it'll send to route 2's fast Ethernet 01 interface, sorry, 10 interface, sorry. If we do show IP route here, do show IP route, we can see we should be able to see 198.51.100.0/24, which we can see slash what we configured was a 240.20/28 subnet mask. Yeah, using that as the next hop, so we can see that route is there. So it's got route there to 192.168.100.0. So it's got route to where exactly 100.0. Yeah, we can see that static route there configured about 198.51.100.3. So we can see an exact route to where VLAN, yeah, to that VLAN where VLAN